Okay, so in this video, we will look at reaction mechanism, right? And we will be doing the reaction of alkanes. So first of all, what is a reaction mechanism? So in chemistry, when we write an equation, we just show the reactants and then we move straight to the products. What the mechanism does is to show a stepwise process by which the reaction occurs. So it's a description or a proposal, right, by which the reaction may occur. So it's a series of steps by which a particular reaction will occur. So before we start to do any reaction mechanism for organic chemistry, you have to know certain terms. So you can pause the video and look at the terms. So the first one is homolytic bond breaking, heterolytic bond breaking. So when a covalent bond breaks, so in organic chemistry, chemistry of carbon atoms mostly, we are dealing with covalent compounds. So when a covalent bond breaks, it breaks in two ways, homolytically or heterolytically. So in homolytic bond breaking, when the bond breaks, each atom gets one electron. If it's heterolytic, one atom will get both of the electrons. So in homolytic, both atoms gets one electron. In heterolytic bond breaking, one atom gets both of that electron. Each atom gets one electron, one atom gets both electrons. You will also need to know what the term nucleophile, electrophile, radical means. So a nucleophile is just a species, right, with at least a lone pair. So when we say an electron sufficient species or an electron rich, it just means it has at least one lone pair. So anything with a lone pair is a nucleophile. If you see any ion with a negative charge, it is a nucleophile. It is a nucleophile. An electrophile is an electron deficient species, right? No lone pair, right? And in most cases, it will have a positive charge. So your nucleophile, electron rich, it has a negative charge or a lone pair. Electrophile, electron deficient, it will have a positive charge. A radical, no. So you must know, pay careful attention to the nucleophile and the radical. The radical is a species with an unpaired electron. It will not have a lone pair, it will just have a single electron. Right? Now, when we're doing a reaction mechanism, we will use a fish hook or a curved arrow, so either the fish hook or the curved arrow, to illustrate the movement of electrons. So let's do some examples of homolytic bond breaking and heterolytic bond breaking. So the first thing I need to know, right, if you want to know if a molecule is going to break homolytically or heterolytically, you need to know if it's a polar or a nonpolar compound. For the compound to be nonpolar, the electronegativity of the two atoms must be close. If the bond is going to break homolytically, it will be a a non-polar compound. In a non-polar compound, the distribution of charge is equal. For the distribution of charge to be equal, the electronegativity of both of your atoms have to be the same or close. If you look at the molecule of chlorine, so the example we're doing is a molecule of chlorine. When this chlorine molecule breaks, how will it break? Because it is the same atoms, that means the electronegativity is the same. And once the electronegativity is the same, it will break homolytically. When a bond is going to break homolytically, we use a fishhook. And in homolytic bond breaking, we said that what? Both atoms will get one electron. Also, you should know that every bond has in 2 electrons. So, for explanation purposes, I'm going to highlight the 2 electrons. So I'm going to use these 2 dots to represent the electrons. So if this bond is going to break homolytically, it means that this chlorine atom must get 1 electron. And this chlorine atom must also get 1 electron. So if you look, when you're drawing the curved arrow or the fishhook, it must start at the source of the electron and it must end at the destination where it is going. So we're moving the electron from the bond and putting it on the chlorine. So you always start drawing your fishhook or curved arrow from the source of the electron. So this chlorine atom gets 1 electron and this chlorine atom gets a next electron. And that is how we show that the bond has been broken. So curved arrow and fishhook is used to show bond breaking and bond formation. In this example, it is just showing bond breaking. So remember, to form the bond in the first place, the 2 chlorine atoms would have shared an electron each. So if both atoms remove both of those electrons, then there is no bond. And so you will end up with 2 atoms of chlorine. Remember, each of them took back their electrons. So what have we ended up with now? An atom with an unpaired electron. And what do we call that? A radical. So here we have 2 chlorine radical. So this is homolytic bond breaking. When a bond breaks homolytically, you will get a radical. So in this example, it is showing homolytic bond breaking. So in homolytic bond breaking, you will generate radicals. So these are radicals. You use fishhook to show that each atom is getting 1 electron. Let's go with the next example now. Let's look at HCl. We know that chlorine is electronegative, hydrogen is not. Therefore, when you have a bond between an electronegative atom and the next one is not, the distribution of charge will not be equal. In this example above with Cl2, it was the same atoms. So the distribution of charge was equal. Therefore, the electrons in the bond were evenly distributed, right? However, because chlorine is electronegative, much more electronegative than hydrogen, the distribution of charge will not be equal. And when I say distribution of charge, what does that mean? Hydrogen and chlorine form the covalent bond. They are sharing. The covalent bond, you share electrons. So, like the chlorine, the electrons are supposed to be evenly distributed in the center, equal distances. But because chlorine is more electronegative, that means its pull on the electron is much greater than hydrogen. It is going to pull the electrons closer towards itself. So because chlorine is much more electronegative than hydrogen, it will pull the electrons closer towards itself. Since the electrons are now closer to chlorine, the distribution of the electron is not equal. So this molecule cannot be nonpolar. The chlorine will have a slightly negative charge. So because the electron density around chlorine has increased, because the electrons from the bond are now closer, the electron density has increased. So it will have a slightly negative charge. While hydrogen now, its electron density has decreased because the electrons have moved closer to chlorine. It will have a slightly positive charge. In this molecule, once you have a charge, we basically call it a pole. So we have a negative pole here and we have a positive pole here. So this molecule has a dipole. So the molecule is said to be polar. So we have a negative and then the positive end, the molecule is polar. The distribution of charge up here in the 2-chlorine molecule, it was equal. So there was no overall negative charge or overall positive charge. So there was no pole in the molecule, so the molecule was nonpolar. However, in HCl, chlorine is electronegative, therefore it pulls the electron closer towards itself, increasing the electron density around it. Therefore it has a slightly negative charge. The hydrogen on the other hand is electron deficient, so it has a slightly positive charge. You have 2 poles existing in the molecule, so the molecule is polar. Hence, this molecule is going to break heterolytically. Right? That means both electrons will go to the chlorine. Now, on the exam, or when you're working the question, these electrons will not be there. But remember, I put them there just for explanation purposes. What you will do is just draw the arrow from the line. Right? And do it like that. This means that the bond is being broken and both electrons are going to the chlorine atom. Once you draw a fish hook, remember we said the curved arrow is used to show the movement of an electron pair. So we are moving both electrons from the bond to chlorine. Every bond has in 2 electrons. So we are moving the 2 electrons from the bond to chlorine. So what will happen as a result? hydrogen now will develop a positive charge because it lost the electron that it shared with chlorine. And chlorine will have a negative charge. It gained an extra electron. So when a bond breaks heterolytically, so this is heterolytic, bond breaking. When a bond breaks homolytically, you will get radicals. However, when it breaks heterolytically, you get a species with a positive charge and one with a negative charge. In other words, you will get an electrophile. You will get an electrophile and you will get a nucleophile. So when a bond breaks heterolytically, you always get an electrophile and a nucleophile. So quick recap. When you get a bond, when you get a molecule, if you want to know if it's going to break homolytically or heterolytically, you need to know first if the molecule is polar or if it is nonpolar. If it is polar, it will break homolytically, and the both electrons will go to the electronegative atom. You will get a positive ion and a negative ion, or electrophile, nucleophile. If the molecule is nonpolar, it will break homolytically. Both atoms will get one electron from the radical. One more example of a bond. The carbon to hydrogen bond. Both of these have similar electronegativity. Once the electronegativity is similar, if the bond is going to be broken, it will be broken homolytically. That means one electron for the hydrogen and one electron for the carbon. So you don't need to show the electrons. Once the bond is there, it means that the bond contains the electrons. So you just draw a fish hook from the bond to carbon. This means that the one electron is going to carbon and one is going to hydrogen. So if that happens, we would have hydrogen with an electron and carbon with an electron. Again, once it breaks homolytically, you will get radicals. Good. So that's what we need to know before we move now into an actual mechanism. And the first mechanism we are going to look at is one with alkanes. And the reaction mechanism we are going to look at, it's called free radical substitution. So we're going to move on now to free radical substitution. So this is the name of the reaction, halogenation of alkanes. But the name of the mechanism is free radical substitution. Let's look at the example. If you have methane and you react methane with chlorine, you will get chloromethane plus hydrogen chloride. Let me just point out this. HCl, when it's in the gaseous state, it's hydrogen chloride. So don't look at HCl and say it's hydrochloric acid. When it's in the gaseous state, it's hydrogen chloride. If you dissolve the gas in water, so now you have a solution. That's when it becomes hydrochloric acid. So I'm just pointing that out. If it's a gas, it's hydrogen chloride, and it's aqueous, it's hydrochloric acid. Right. So methane plus chlorine will give a chloromethane plus hydrogen chloride. This is the equation. What we are going to do now is to try and write down a mechanism, a stepwise proposal by which this reaction occurs. So let's start out. The first step in the mechanism is called initiation. And when you're doing your mechanism, you must always annotate. So what is going to happen in initiation? In initiation, we will have formation of free radicals. So step one is initiation. And in initiation, we will have formation of free radicals. The free radical is going to come from the molecule of chlorine. So here you have your chlorine molecule, but we said we are going to generate radicals. How can we change the molecule into radicals? The bond must break. If the bond is going to break, how will it break? Both atoms are the same, that means they have the same electronegativity, therefore it will break homolytically. So this chlorine atom gets 1 electron, this chlorine atom gets 1 electron. If you draw a curved arrow, it's wrong. You have to use fishhook. And remember, what's a radical? Species with an unpaired electron. So in step one, it's the formation of free radicals. We have just converted our chlorine molecule into chlorine radicals. And that's it for step one. But for this reaction, it must occur in the presence of UV light. So when you are doing this mechanism, ensure you put UV light over the arrow. So this reaction, this step will only occur in the presence of UV light. So it should also be up here. The next step now is propagation. Again, we have to annotate. So what will happen in propagation? So for this specific reaction, it's between methane and chlorine. So in propagation, the general sequence of events is that a radical is going to attack one of your molecules to generate a new radical. In this case, the radical we have is chlorine. So the chlorine radical is going to attack your methane molecule to generate a new radical, which in this case will be the methyl radical. So let's go and draw methane. So we have methane, and it is reacting with the chlorine radical. Now, the word attack. When we say the radical is attacking the molecule, what it means is that your radical is going to try and form a bond with one of the atoms. When we say attack, it simply means that your radical is trying to form a bond with one of the atoms of the molecule. In this case, your chlorine radical is going to try and form a bond with hydrogen. In order to form a bond with this hydrogen, the bond between the hydrogen and the carbon will be broken. So in order for chlorine and hydrogen to form a bond, the bond between carbon and hydrogen has to be broken. So again, how will the bond between carbon and hydrogen be broken? Because when this bond is going to be broken, you need to know if you have to draw a curved arrow or a fish hook. If you don't put in the curved arrow or a fish hook, your mechanism is incomplete. So we already know that carbon and chlorine, carbon and hydrogen, the bond between them is nonpolar. Therefore, if it is going to break, it is going to break homolytically. So hydrogen gets one electron, carbon gets a next electron. Good? Now, I said earlier that every bond has in 2 electrons. So chlorine has 1 electron, hydrogen has 1 electron. So the 2 of them now can share each electron to form a bond. And that is what is going to happen. The chlorine radical is sharing its 1 electron with hydrogen. So how do we show bond formation? The 2 fish hooks are facing each other. That is showing that a bond is being formed between the hydrogen and the chlorine. And this one now is pointing towards the carbon. Carbon is getting 1 electron. So what will be the products? Let's look at the curve. Let's look at the fish hook again, and it will tell us what is occurring. This bond right here, it is being broken, right? Homolytically. So over here, we will not have a molecule of methane anymore. We cannot have methane because the bond was broken. It was broken homolytically, so that tells you that hydrogen must come off, that's one, but an electron must be here because carbon got 1 of the electron. And once you have a species with an unpaired electron, that is your radical. So this is your methyl radical. What else occurred? A bond was formed between hydrogen and the chlorine radical. Therefore, you must have a molecule of hydrogen chloride. So let's go again. In this step, the chlorine radical is attacking your methane molecule. When the attack is going to happen, right, for a bond to be formed between hydrogen and chlorine, the bond between that hydrogen here and the carbon has to be broken. Both of this bond here, it's non-polar, it is going to break homolytically. That means carbon gets 1 electron and hydrogen gets 1 electron. The hydrogen uses 1 electron to form a bond with chlorine. You ensure that the fish hooks are facing each other to show that the bond is being formed between hydrogen and chlorine. And so we get hydrogen chloride and the methyl radical. Now propagation has 2 steps. This is step 1. Remember, if you pay attention here, we must end up with chloromethane. At the moment, we still have no chloromethane. So in step 2 now, so just remember, in propagation, the general sequence of events in any step is that a radical will attack a molecule. So here now, we are going to use our methyl radical. So here we have the methyl radical, and it is going to attack a chlorine molecule. So the methyl radical is going to attack a next chlorine molecule. Remember, it's 2 chlorine atoms. The molecule is non-polar. If it breaks, it's going to break homolytically. So this chlorine will get 1 electron, this chlorine will get a next electron. This carbon here has an electron. Remember, if you have 2 fish hooks facing each other, it means a bond is being formed. So you have the fish hook, this fish hook from the carbon atom facing the fish hook from this chlorine. It means that carbon is using its 1 electron to form a bond with this chlorine. So what should be our product? Clearly, we have a bond being formed between the methyl radical and chlorine, or between this carbon atom and chlorine. So you must have a carbon to chlorine bond as the product. On the reactant side, we see that a bond is being formed between this carbon atom and this chlorine atom. So on the product side, that bond must be shown. So you must have carbon to chlorine bond. Nothing else occurred on the carbon atom. Everything else stayed the same. So you must have back here 3 hydrogen atoms. What else occurred? The bond between the chlorine atoms were broken, and 1 chlorine atom came off, right, with 1 electron. So there you go. We always generate a radical. So in propagation, 1 radical always attacks a molecule to generate a new radical. And it's the same thing here. The methyl radical attacks the chlorine molecule to generate back a next chlorine radical. And that is propagation for you. Now the reaction, it doesn't have to stop here, because this chlorine radical, it can come again and do back this very same step. So this chlorine radical could come and remove a next hydrogen to generate a next radical. But I will do that in a next video, show more than 1 substitutions. So the objective was to show you how chloromethane was formed. This is how chloromethane was formed. Now, once you have radicals present, the reaction will continue. So for the reaction to stop, we must have termination. So in termination, put it away. In termination, free radicals combine. Example, two chlorine radicals can combine to form a molecule of chlorine. Two of the methyl radicals can combine, and let's do this. Alright, so two of them can combine, you get a molecule of chlorine. Two methyl radicals can combine, and you will get a molecule of ethane. And of course, as was in the propagation step, a methyl radical combines with chlorine radical. You will get chloromethane. If radicals are present, the reaction will continue because your radical is going to always attack your molecule. So for termination, which is when the reaction comes to an end, your free radicals will combine. When two radicals combine, you always get a molecule because each radical has one electron each. So if they share them, they are forming a bond. Two methyl radicals share one electron each. That is how we get the bond here. So let me put the electrons in blue. So these two electrons were shared. Once they were shared, a bond was formed. Same thing again. Here. And that is free radical substitution.